That's how it goes.
I am associated with these.
I need to pull up the times when you said you were gone in a sentence.
When did I say that?
I'm sure you said it.
It's true and honest. Why do you like throwing
Well, it
that
depends
at
Hey,
what
my
type of
reaction
you're
to
talking
words.
about.
Let's go.
Alright, let's discuss our results. Okay,
Just
so
a random
Results.
what happened when you put soda in the hot water? What happened?
Bubbles.
Bubbles. You saw bubbles going up. Was there? Yes.
Well, I have a solution of why that was happening. The
Okay.
heat probably compressed the carbon dioxide and it came out through gases. So it's fine.
Okay, not compressed, but yes, the carbon dioxide is coming off. What's happening to gases as they heat up? Ted.
When gases heat up, they expand, and it's trying to get away. So
Yes, that's right.
Trying to
Expanding and floating out. Okay. So was there a difference between Coke and Pepsi?
Not really. Well, no. Yes.
They both did the same thing, but what were your observations?
I thought Pepsi had a lot more bubbles in general.
You went back and forth more times?
Yeah, I went back and forth with both of them, and the Coke died on the second time I put in the heat, but the Pepsi had it until the fourth time.
Did anybody else notice a difference between Pepsi or Coke? How many bubbles you got?
There was little to no bubbles in the Pepsi, but a heck ton of bubbles
Oh,
on the
you
Coke.
had the opposite.
Maybe
Okay.
it differs from can to can.
No, I don't think so. But what do you notice when you pop open a Coke? What do you notice?
Great noise.
Yeah, what do you think is happening there?
The gas is
Yes.
escaping.
The gas is escaping. It's bottled under pressure. So remember, in this module, we talked about what effect pressure has on the solubility of gas. What is that? What's the purpose of that pressure in the can? Okay.
the pressure doesn't the chemicals and like the pressure keep its pressure for longer, and also it's like nice.
The pressure keeps the bubbles there.
Yeah.
Keeps the bubbles
Keep the
in the
bubbles.
solution. Yes. And then depending on your altitude or where the temperature you open it at, you get that little psh, right? But there's always going to be some because it's under pressure. What do you think would happen if I just took a closed can of Coke and put it on the heater?
It'd be
I think it would explode.
We should find out.
Wait, we should do
The
that.
pressure would be
Do it.
No, just go.
I would be a
over
little bit nervous to do that. I'm not sure exactly how it would explode,
It's
but
just a
I'm certain it
rudimentary
would
bump.
explode
Well,
at some point.
The least resistance would probably be the top,
Probably.
but the most heat is at the bottom, so it might go at like the bottom. I don't know.
We can
Well,
explode
then
Coke.
what I would assume would happen is it would explode at the weakest point.
So maybe you should
However-
store Coke bottles in your hot car, right?
Heat might have something to do with metal.
I'm sure there must be a
That might
YouTube
weaken
video
at
of that
certain
happening.
points.
Somebody that stored hot Coke in their
The
car.
metal there.
No,
Okay.
no. I'm just saying that
All right,
might do something to it.
What happened when you put it on the ice water?
It stopped the bubbles.
Stopped it, pretty much. No bubbles,
It
right?
also tasted
So what's happening when you're getting it cold?
good.
Like he said, if it was expanding when it's hot, then it's contracting when it's cold.
The bubbles are contracting, the gas is dissolving more into the liquid, right? You can't see those bubbles in there anymore, but it's more dissolved at lower temperature. There's more gas dissolved in the liquid, right? The gas is still there. And so this is the way it is in rivers and stuff too. You don't see bubbles in the water, but there's oxygen dissolved in a river. That's how fish breathe, right? So if for some reason that oxygen is consumed, then the fish have trouble breathing and you'll see large die-offs.
Ready?
Okay, let's see. All right. Did you start yet or not? You did? Okay. All right, good.
He's just gonna be watching this.
Okay, well, and so we're just gonna go over and make sure we have this idea of solute and solvent and all that solid in our heads. What's happening here?
No, I have to write it
Push that over. Okay, so what is a solute? What's the definition of a solute? You were about to go.
It's not ideal.
Just give it a stab.
So the solute would be, if we're talking about Coca-Cola, then the solute would be the stuff. It would be the chemical reaction inside
It's this.
Okay, that's a really bad.
Close. It's the stuff that's dissolved in it. So what kind of solutes are in Coke?
Sugar.
Sugar is a solute
Syrup.
in Coke, yeah.
Carbon
The
dioxide.
caramel type of syrup. Yes, and what? Somebody saw it over here.
Sugar.
Carbon dioxide.
Carbon dioxide is a
Sodium.
gaseous solute, right?
Caramel
So-
color.
Caramel
Sodium,
coloring.
carbs.
That's a
No
solute.
vitamin D though.
Fructose, corn
Okay.
syrup, caramel color, phosphorus acid, nitrogens and flavors,
What's
caffeine, salt.
what's the solvent in Coke?
That's not.
Would be the thing that the thing is dissolving into, like, for example, would be the water. That
It's the water.
is
Yes.
there water in this?
There
Yes.
is water in Coke. It's primarily a water-based thing, but
First
there's so much
ingredient,
stuff in
water.
it for flavor and sugar and right and carbon dioxide. But the main component, the solvent, is the thing that there's the most of. So the solvent is water in your Coke, and then the solute, what we looked at today was the gas. But we could have done something involving the sugar as well, just like we did with the salt last week. Okay, and then oh, I just lost my train of thought. Solvent. Oh yes, so like air. Air is a solution. What's the solvent in air? Does anybody know the solvent
Oh,
in air?
nitrogen.
What? Say it again, real loud. Nitrogen, because air is 80% nitrogen, and so then you would think, okay, so what are the solutes in air?
Oxygen.
Oxygen,
Water.
carbon dioxide. There's helium. There's some water vapor in there. Yes, very good. Okay, excellent. All right.
Sometimes there's other things in the air.
All right. So what is when we say solubility? What is the solubility of a solute? What does
Like a fire?
solubility mean?
The
How well it How
how easy it is to become
How easily it dissolves.
mixed.
Okay. So solubility is the maximum amount of a solute that you can put into a solvent. All right. So if you say if somebody's saying like the specific solubility, what's the solubility of sugar in water? There's a maximum amount of sugar that you can put in before no more will dissolve.
I think it's a lot.
You'll just get extra. It's a lot.
I think it's a
You'll
lot.
just get extra crystals on the bottom.
For the
And that's when you get to that saturated solution. When you see crystals on the bottom, now you've got that saturation state.
I mean, for
But
salt,
solubility means the maximum amount. So there's a limited amount of carbon dioxide, the maximum that they can press into that sugar water, right? That would be the solubility of carbon dioxide in sugar water, okay? And that's one thing that was different. As it's getting colder, so not all gases can be forced to dissolve into sugar water. You have to, the solvent has to have affinity, it has to have attraction to that gas and enough to pull it together into little bubbles dissolved in that solvent. Okay. Let's see. Oh, on what does solubility of a solute depend? We've experimented with this in different ways last week and this week.
Temperature.
Temperature. It's temperature dependent, except for what kind of solutes? What solutes are not affected by temperature? No, today we found out gases are affected by temperature, right? And last week we experimented with solids and they were affected by temperature.
Liquids.
Liquids. So liquid and liquid, dissolving a liquid in a liquid, it's not really affected by temperature or pressure. And
It's just
it just is. Yeah.
Plasma. Bosons.
Okay, so what causes the solubility of a solid to go up? What makes a solid more soluble? Heat.
Temperature again.
Last week we did this, yes.
pressure,
Pressure does not affect the solubility of a solid much.
much.
Well, let's say it doesn't. Okay. Pressure is not affecting the solubility of, it's only affecting the solubility of a gas. Okay. What causes solubility of a solid to increase? If you make the temperature go up, you usually, remember we talked about, usually the solid, you can dissolve more of it in. So the solubility is going up. If you decrease the temperature, what happens to the solubility of a solid? If I make it cold.
It's gonna dissolve less quickly. It's gonna dissolve less quickly, right?
It's gonna dissolve less, period.
Yes.
Even, you know, like when we took our beaker of salt and it was hot and then we put it in the freezer, what happened?
Crystals.
Crystals, you got a precipitate. Yes. So some of that solid had to come out because it's less soluble when it's cold. Okay. Is a liquid solute affected by temperature? I kind of just went over that. No. That's right. How does temperature affect a gas solute? Temperature, if it gets hotter, is the gas more or less soluble? Less soluble. It's less soluble. The gas is coming out, but that's showing you that it's less soluble when it's hot. Okay? When it's cold, is a gas more or less soluble? More soluble, yes. When it's cold, because the gas is not coming out, it's staying in. Okay. All right. Pressure increases solubility gas. It makes it more soluble when you increase the pressure. Does pressure affect the solubility of liquids or solids?
Yes.
If I press on liquid solution, liquid solution, is it going to become more? No, Angelina's saying it. Okay, if I had that salt solution with crystals on it and I pressed on it, yes.
Oh, no. Can you finish what you're saying? I think I might be on the wrong question.
Yes. Does pressure increase the solubility of a solid? So if I have a saturated solution of salt and I've got some crystals on the bottom, if I press it, am I going to get more salt to dissolve? No. It's not really compressible. Gases are compressible and they are affected only, their solubility, by pressure. Okay. Oh, that's interesting. Strong base or a strong acid, is that in this? Is that even in this? That's a different module entirely.
I could tear this in half.
This feels really weird.
What are you doing?
Scrolling up on the calendar.
Oh, okay. So this is talking about, this is referring to the exothermic reaction that we observed. When we dissolved sodium hydroxide, what happened? Did it get a little hot? Did it get a lot hot? A little warm? What happened?
Warm.
A lot hot. It was very exothermic, okay? So that is an indicator that that's a very strong base, okay? Strong acids, strong bases are gonna react strongly like that.
Nice.
Okay, releasing lots of heat, that's why, yeah. So know the difference between exothermic and endothermic. Let's see.
So loud.
What's the difference between molarity and molality? Molarity and molality. Who thinks they can tackle that?
Molarity is volume and molality is weight.
When you're talking of yes, be more specific. That's true.
So molality molarity is liters, right?
Yes.
And molality is kilograms.
Yes. So, and more specifically, molarity is liters of the total solution. That's the solvent and the solute together. And then molality is kilograms of the solvent. But yes, that's the difference. Okay. And they both have moles right on top. Okay. Let's see, do we want to work this one?
Sorry.
Oh, okay, there it goes. Got it.
Just imagine I did it, but there's like no proof for actually scrolling this side.
Just take screenshots.
Oh, I am. But every 10,000.
Let's see.
And then I took it on 22, 22, 22, 22.
let's solve these problems. Let's work these problems. And I'm gonna switch this off.
60,300.
Go to this.
And we can do it.
All right. If you have a back of a paper or something you can work on.
Go to 11,000.
All right. We're gonna calculate the molality of a couple things.
Back in my
So
The molality?
So the first problem says 2.3 moles of sodium hydroxide are dissolved in 1.2 kilograms of water. Okay, guys. So if I have 2.3 moles of sodium hydroxide, okay. Also not tilting the way I want it to. Okay, and it's dissolved in.
It's dissolved in
1.2 kilograms of water. Which one is the solute?
Saw you guys, not all.
Yes, sodium hydroxide.
Nailed.
So the water is the solvent. All right, and I want to calculate the molality. So molality equals moles solute divided by kilograms of solvent. That's why we were trying to be real careful about making sure you understood solute, solvents. Okay.
So peaceful.
All right, and this one's fairly straightforward. We're given the amount in moles already. So we know it equals 2.3 moles. And go ahead and write the symbols so everything stays straight. That's the number of moles we have of sodium hydroxide, and it is dissolved in 1.2 kilograms of H2O. Okay, nothing's going to cancel. We're just going to do the math. What do we get? See if we can get some agreement. Plug it in your.
3
2.3 divided by 1.2.
kg. Forgot to bring my scientific calculator today.
1.9.
Mistakes have been made.
1.91.
So,
Six.
okay, yes, and it keeps on going and going and going. So should I put the 1.91 or should I put 1.9? 1.9. Because I've got two significant figures and two significant figures. Keep it at two significant figures. So 1.9. I don't need to write all this stuff down. I just need to write little m for molality of sodium hydroxide. Okay. All right, that's a pretty straightforward one.
1.9. No.
No.
So make sure you do the little m.
You have NATO. Sodium might be
All right. So now, next one, I have 250.0 grams of potassium nitrate dissolved in on the roof. Okay, thank you. Dissolved in 2.43. Am I running off the edge yet? That's a 3. 2.43 kilograms of H2O.
No.
Okay. All right, I want to calculate molality. Okay, what's the solute?
Is that a 5? That's 5.
Which one is the solute?
Which one is the solute?
Yes.
It's the grams.
What?
K and L, right?
What? You agree with that? Yes.
Yes.
Potassium nitrate is the solute. I also know that I
You have
can.
to convert it.
You do. You have to convert it to. But I know that I can look at my periodic table and say potassium's a metal, nitrate is a polyatomic, This is an ionic compound. It's going to dissolve in water. Okay, but this is in grams, right? But if I want molality, I have to convert 250 grams into moles. My solvent is already in kilograms, so I don't have to convert that. But anyway, so if I start out with just 250.0 grams, I'm going to put my symbol here just to keep everything straight. All right, what do I need to do to convert that to moles?
Divide by 1,000.
Wait,
Don't
No,
you have to
divide
Divide by
it's-
1,000 to get moles.
It's
To
grand.
get-
Divide
Oh
by
wait, no, you have to have the number thingy.
What?
You have to have the number
Divide
thingy.
by 101.105.
Oh, did you already figure out the molecular, the molar mass?
Yeah, I was about to do
Okay,
that.
so you're gonna go to your periodic table and you're gonna calculate your molar mass. And Riley got,
I was
tell
right.
me again what you got.
101.105.
101.5,
105.
105. So we're gonna call that 101.1 grams. Oops, KNO3 per moles per 1 mole of KNO3. So now you see my grams of KNO3 cancel out, and I end up with moles of KNO3. Okay, and we're gonna keep going and put in the solvent there. So I've got 2.43 kilograms of H2O. So am I in molality now? Now I've got moles of KNO3, potassium nitrate, over kilograms of H2O, right? So now I'm in moles per kilogram and I'm good. Just have to plug in my math. So do 250 divided by, use parentheses, 101.1 times 2.43.
It's gonna be about.
Wait, parentheses.
Yes, use your parentheses. Common mistake.
260. So either way, you wait. No. Zero or worse. So.
And then we
you're
multiply
250 into
the parentheses by the thing?
Okay, fine.
No, it's on top. 250 is divided by parentheses 101.1 times 2.43
Times.
close parentheses.
Actually, no. 500.
Okay. So what did you get?
Just about.
4. Is that 3 or 5?
It's a 3.
Alright, that's fine.
Yeah.
260.
What'd you guys get?
We have
Okay, calculate it out. I want to
the
know.
whole thing.
I want to make sure you know how to do this. Yes.
1.1. I can't do it.
I hope I did alright.
Divide by that. Hold on, I gotta make this. No. So you
Slide up. Slide up. No.
So,
All right. Someone have an answer for me? What'd you get, Zane?
I don't know if I got this right. 6.00 something. Don't think.
Try again. 250.
Is that 2.5 or 2.3? Or 2.45 or 2?
2.43. Sorry.
Wait.
So 250 divided by
1.01.
we were both way
I got that's for the whole thing.
one. Do you have an answer, Ted?
1.02.
Yes. Go to the next digit, guys, and round up. You're close. It was 1.0176, blah, 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 keeps going, right? But let's look at this and we can evaluate for which significant figure we could use. This one has 4 significant figures. This one has 4. This one has 3. So we're going to do 3 significant figures. And it's moles potassium nitrate over kilograms of water, and that's just molality. Okay, put your little M. for molality. All right, any questions?
That number.
All right, practice. Did you get it the next time? Did you practice with using your parentheses?
Yes.
Okay, good.
All right. Now I know where I messed up. Okay.
Good.
Good to know.
Okay.
Because all this has to be divided by, not multiplied by 2.43. That's where I got it wrong.
If you wanted to do divided by 101.1 and then again divided by,
Yeah.
you could do it two separate steps, but it's a lot faster and easier if you get used to using your parentheses. Okay. All right, acetic acid has a KB of 2.93. They're giving you the KB of acetic acid. Acetic acid has a KB of 2.93 degrees Celsius per molality. All right, bring that down. Okay, and a normal boiling point of 118. So that is giving you the initial temperature. The normal boiling point is 118.1 degrees Celsius. What would be the boiling point of a solution made by dissolving 50 grams of calcium carbonate? Okay, so we have 50 grams, 50.0 grams calcium carbonate into 500 grams of acetic acid. Okay. Which one is the solvent?
50
Solvent.
Oh, 500 grams of acetic acid. Not the sodium.
Okay, we've used acetic acid. What is acetic acid?
Acetic acid would be our solvent, right?
Yes, correct. What is the acetic acid called that we
Is it
do?
vinegar?
It's vinegar, yes.
Fine.
Okay, and then calcium carbonate would be the salt that we're dissolving. The solute, yes.
Wish I could just do a little spritz and remove everything else.
Okay, so what is T? We don't know TF. That's what we want to find. What would be the boiling point after we dissolve this?
No.
We need to try and find TF. Okay, so this is going, first I'm going to look at calcium carbonate. How many particles does calcium carbonate dissolve into? And I want to find I, because I also I don't know I, right? It's 2. Yes, a calcium and a carbonate. So I equals 2.
Isn't there 3 carbonates or something?
There are 3 oxygens, but this is a polyatomic ion. It stays together. The CO3 stays together. All right, that's why we had to work on memorizing our polyatomic, because we keep using them. All right. So we figured out our I by figuring out how many particles it dissolves into, and it's likely that you'll have a problem like that on the test where you need to figure out I, because it's a fairly simple process to find I. Okay, and we don't know we don't know M either, but we have enough information to figure it out. To figure out the molality. Let's figure out the molality of this problem. So 50 grams of calcium carbonate. Convert it to what?
Convert the 500 to kilograms and then convert the 50 to moles and then you have your
That's
thing.
correct. Very good. Okay, so this one's easy, right? We could just go move it over and say we've got 0.5 kilograms. Now,
And then
right? Now 50 grams of calcium carbonate. Let's figure that out. 50 grams calcium carbonate. What's the molar mass of calcium carbonate? Can you figure that out?
This is 100.1.
100 and
100.1.
Why are you calculating this so fast?
they're working ahead.
Oh,
So you take the weight of calcium plus the weight of carbon plus 3 oxygens. I'm not double checking that, but
Are you sure
I'm gonna trust you. Okay,
50.
all right. That's gonna give me moles of calcium carbonate. What does that equal, guys?
1 mole.
So 50 divided by 100, pretty much.
0.1 G Ca CO3. SCG 110% guaranteed.
Now I'm gonna actually
Alright.
use myself.
Done.
I'll do it myself.
0.500. What do I got?
Calcium 4.001
Moles.
plus
All right, and you're going to divide that by 0.500 kilograms. Oh, isn't that nice and neat? Right? This is acetic acid. Okay, 0.5 over to 0.5. I ended up with 1 mole.
Nice.
So nice. Calcium carbonate.
Oh wait, this is the equation in the book.
No.
You realize this now because we got.
Right, now you've got the M, which is 1.
I know the answer.
And then you just plug everything into the KB formula that you need to memorize, right? The boiling point depression, it is, okay, so
Gotta know where I got all my stuff.
It's hard to tell.
let me go down here, let's see, okay. So the main equation that we're gonna plug it all into is let's see, we've got
This is no
delta
good.
T, you just have to memorize this, delta T equals I, K sub B.
Is it negative I?
Nope, because that's freezing point 1.
Okay.
But if you're given KB, I know I'm looking at boiling point 1. So, thank you for checking though. All right, and delta T is T final minus T initial is delta T.
1, 2, 3,
And I want to solve that for T final is what I'm going to solve it for. All right, you guys following me in this mess? All right, so I'm going to add a TI to this side, and I'm going to add a TI to this side. Okay, so that I can get rid of that. And then I'm solving for T final. That's going to be my final answer. All right, so I is 2 times K sub B, it was given to me. Back up here at the top, 2.93 degrees Celsius times molo.
Just look at the pole.
Up there.